All right, today we're going to take a trip, a world tour, to uncover the surprisingly global roots of science. We're going to challenge some common ideas and discover this incredible story of human curiosity that stretches across continents and thousands of years. Let's dive in.
So when I see the words ancient scientist, what's the first image that pops into your head? For a lot of people, it's probably a Greek philosopher, right? Maybe in a toga. And look, that's not wrong, but it's only one tiny piece of a much bigger and honestly a way more fascinating picture. You know, today we picture science with lab coats, supercomputers, massive particle accelerators. But the ancient reality? It looked a lot more like scribes carefully carving data onto clay tablets. It was astronomers mapping the stars with simple charts and surveyors using basic tools to build stuff that still stands today. The tech has obviously changed, but that basic human drive to figure things out, that's always been there.
So let's get into our first section here and explore what science looked like before the word science even existed. This was all about a fundamental human quest to understand and predict the world around us. And that quest got a massive power-up from one of the most important inventions ever: writing. Okay, so for this all to make sense, we need to get on the same page about what we even mean by ancient science. We're not talking about controlled experiments in a lab. Nope. This was all about systematic observation, watching the stars, tracking the seasons, and, this is the really crucial part, recording it all, so that knowledge could be saved, shared, and built upon by the next generation. And that brings us right to our first stop, the ancient Near East. In these fertile lands, in Mesopotamia and Egypt, civilization just exploded. And with that came all these practical problems that could only be solved by one thing: collecting and analyzing huge amounts of data. The Mesopotamians, they had this revolutionary tool: cuneiform writing on clay tablets. I mean, think about it. For the very first time, they could record incredibly detailed numbers about the cosmos, the paths of the planets, the moon, the stars. They created astronomical records so accurate that people were still using them for centuries. At pretty much the same time, over in Egypt, science was being born from the rhythm of the Nile River. Every year, it would flood, which was great. It brought all this fertile silt, but it also washed away all the property lines. So to keep society running, they had to be able to accurately resurvey the land year after year. This very practical need is what pushed their amazing advances in geometry. So you can see right here how these two great civilizations took different paths, all based on their needs. For Mesopotamia, the sky was everything. It was their clock, their calendar, a way to read messages from the gods. So they poured their energy into mathematical astronomy. But for Egypt, it was all about the earth beneath their feet. They needed to redraw boundaries and build tombs that would last forever, which led them to master practical geometry. They famously used the 3-4-5 triangle to get perfect right angles for their incredible buildings. Okay, our tour now jumps over to the Greco-Roman world, because this is where a really profound shift happened. Thinkers there started to move beyond just recording what was happening, and they began to ask this incredibly powerful new question: why? And this was a total game changer. You had people like Thales, who was one of the first to say, hey, maybe earthquakes aren't caused by angry gods, but by natural forces. You had Pythagoras, who started looking into the pure abstract beauty of math itself. And then you had Plato and Aristotle, who gave us deductive reasoning, basically a toolkit for how to think logically, how to build an argument step by step to arrive at a conclusion you know is true. And nobody represents this leap better than Euclid. His book, The Elements, it laid out a recipe for proof that is still, to this day, the backbone of mathematics. You start with clear definitions, you state some basic truths you know are undeniable, and from there, you build a logical proof. This set a standard for rigor that would define Western science for all time. And the results of thinking this way? Oh, they were absolutely incredible. Way, way before Copernicus, you had Aristarchus proposing that the Earth actually revolves around the sun. And then there's Eratosthenes, who used basic geometry to calculate the circumference of the entire planet with stunning accuracy, using just sticks and shadows. Just amazing. But hold on. This explosion of knowledge wasn't just a Mediterranean thing, not even close. Let's pivot our world tour eastward, because at the exact same time, there were intellectual revolutions happening in India and China that would literally change the world. This right here, what you're looking at might just be one of the single most important inventions in all of human history: the number zero. The concept of zero as a number with its own symbol was developed in India. It wasn't just a placeholder. It was a completely revolutionary idea that made the entire decimal system possible. It's the foundation for algebra and, well, all of modern math.
Meanwhile, over in China, innovation was on fire, leading to what we now call the four great inventions. Papermaking and printing didn't just store knowledge, they made it accessible, completely changing how information could spread. Gunpowder was a chemical marvel that reshaped warfare forever. And the magnetic compass, it didn't just point north, it opened up the entire globe for exploration and trade. Each one of these was a world-changing technology.
For our final stop, we're going to a place that makes our main point impossible to ignore: the Americas. See, the civilizations here in Mesoamerica, they developed in complete and total isolation from everyone in Europe, Africa, and Asia. And yet, their scientific achievements were just as remarkable.
And that's where we find the Maya. Now get this. With absolutely no contact with India, no way of knowing what was happening halfway around the world, they independently came up with the concept of zero. I mean, just stop and think about how profound that is. It suggests that some ideas are so fundamental, different cultures are just bound to discover them. They also created a complex base 20 number system, amazingly precise calendars, and a whole writing system to record everything.
So what does this all tell us? What the Maya prove so powerfully is that the scientific impulse, that drive to observe, to record, to understand how the universe works, it's not the property of any one culture. It's a fundamental part of our shared human heritage.
To really wrap this all up, let's just follow the journey of one of those powerful ideas, our numbers. It all starts in India around 500 AD. Then, the Islamic world adopts it, refines it, and transmits it westward. By about 1000 AD, these Hindu-Arabic numerals finally arrive in Europe. And today, they're the global standard for everything. It's a perfect illustration of how all these ancient streams of knowledge flowed together to create the modern world.
So that leaves us with one last big question to think about. You know, from the flooding of the Nile to the need for a good calendar, so much of ancient science was born out of necessity. It makes you wonder, right? What are the great necessities of our time? And what incredible new sciences will they inspire? Thanks for joining me on this tour.